An Armstrong number is a neat little curiosity. Take a number like 153. It has 3 digits. If you raise each digit to the power 3 and add them up, 1 cubed plus 5 cubed plus 3 cubed, you get 1 plus 125 plus 27, which is 153 again. When that happens, the number is an Armstrong number. The plan has 3 parts. First, find how many digits there are, because that count is the power we use. Then walk through the digits, raising each one to that power and adding it to a running total. Finally, compare the total to the original number. If they are equal, every digit contributed just the right amount, and the number is an Armstrong number. We save the original, then count the digits by looking at the length of the number written as text. We start a total at 0. While digits remain, we take the last digit, raise it to the power equal to the digit count, and add it to the total. At the end, we check if the total matches the original. Let's build it live and test a couple of famous Armstrong numbers. Save the original, count how many digits it has, and start a running total at 0. For each digit, raise it to the power of the digit count and add it to the total. Return whether the total of the powered digits equals the original number. Now, let's test it and hit run. $153 and 9,474 are both Armstrong numbers, so they come out true. 123 is not, so it is false. Here is the flow. Count the digits up front. Then for each digit, add its power to the total and drop it. When the number is empty, compare the total against the original and answer true or false. We visit each digit once, and for each we compute a power. There are about log n digits, and raising to a small power is cheap. So this is very fast in practice, using only a few variables, so constant space. 2 mistakes to avoid. The power is not always 3. It is however many digits the number has, so this works for numbers of any length. And as always, save the original before the loop and make sure you have counted the digits before you start summing the powers.